Okay, so today we will be learning how to use the basic formulas for integration. Here, the first one is the integral of 0 dx equals c, which is the constant of variation. The second one states that the integral of x to the n dx equals 1 over n plus 1 times x to the n plus 1 plus c, and n cannot equal -1. The third formula states that the integral 1 over x dx is equal to natural log of the absolute value of x plus c. The fourth one states that the integral of e to the x dx is equal to e to the x plus c. Number 5 states that the integral of a to the x dx is equal to a to the x divided by ln of a plus c. A is greater than 0 and a cannot be equal to 1. The sixth formula states that the integral of sine x dx is equal to negative cosine x plus c. The seventh one states that the integral cosine x dx is equal to sine x plus c. The eighth one states that the integral 1 over x squared plus 1 dx is equal to arctan x plus c. The ninth one states that the integral 1 divided by the square root of 1 minus x squared dx is equal to arcsine of x plus c. The 10th states that the integral 1 divided by cosine squared x dx is equal to tangent of x plus c. The 11th one states that the integral 1 over x plus a dx is equal to ln of the absolute value of x plus a plus c. The 12th states that the integral ln x dx is equal to x times the natural log of x minus x plus c. The 13th states that the integral of 1 divided by x squared plus a squared dx equals 1 divided by a arctan of x divided by a plus c, and a has to be greater than 0. So before class next week, I want you to memorize these basic formulas for integration. Memorize them so that if I should give you a quiz or anything, you'll be able to know how to solve them. Alright, so I want to show you how to do some basic problems using these formulas. So using the formula that I taught you the other day, the integral of f of x plus g of x dx is equal to the integral f of x dx plus the integral g of x dx. Solve the following integrals. Okay, so the first one I've got on here is the integral 1 divided by x plus natural log of x plus cosine of x dx. Alright, so this problem is equal to first 1 over x, the natural log, or I mean the integral 1 over x is equal to ln of the absolute value of x. Then natural log of x, the integral of that, is equal to x times natural log of x minus x. Then the integral of cosine x is equal to sine x. Then you add your constant of variation, plus c. So that's how you would solve a problem like this. Alright, now the second one is set up in the same way, but it uses different formulas. Alright, so first of all, 1 divided by x squared plus 1. The integral of that is equal to arc tangent of x. Then the integral of 1 over x squared plus 9 is equal to 1 over a, and in this case a would be 9, or a would be 3, because 3 squared equals 9, times arc tan of x over a, and a equals 3. Then you got to add your constant of variation, plus c. So that is how you'd solve this problem. That would be the answer to the integral 1 over x squared plus 1 over x squared plus 9 dx. Now for this one, integral of sine x minus 1 divided by the square root of 1 minus x squared dx. It's set up a little differently, but you solve it pretty much the same way. So the integral sine of x is equal to negative cosine of x. Now, since there's a minus there instead of a plus, that don't really change much, except after cosine you put a minus instead of a plus, just like in the problem. Okay, so the integral of 1 divided by the square root of 1 minus x squared is equal to arc sine of x. Then that is your answer to this problem. Then you add your constant of variation plus c. So for class Tuesday, I would like you to solve these problems. The integral 1 over cosine squared of x plus a to the x dx. The integral of x to the third plus e to the x plus 1 over x plus 3 minus sine x dx. And the integral x to the fifth minus a to the x minus ln of x dx. So basically for homework, I want you to memorize the basic formulas of integration that I showed you earlier and complete these 3 problems. And in class we'll go over them and I'll answer any questions you have. So that's all for today. Just do your homework and show up to class and you'll be fine.